Okay, we're going to do a few problems here, just a little practice with the algebra of these inverses here. So now, what this says is we want, when you're looking at the arc cosine, you're trying to find an angle whose cosine is -1/2. Okay, that's what you're trying to do. So if you call this y, for example, then that means cosine of y equals -1/2. So you need to tell me what value of y makes that happen. And it has to be a number between 0 and pi, because that was the restriction for our range value for the arc cosine. So -1/2 would make that 2 pi over 3. Okay, cosine of 2 pi over 3 is -1/2. Okay, and now over here, again, if you want, let's say, okay, inside of here, the sine of 3 pi over 2 is a -1. So now we want the arc sine. So what angle has a sine equal to -1? Well, we know it's 3 pi over 2. However, that number is out of the range. We have to put a number in the range of the arc sine, which is -pi over 2. That would give us the same -1. Okay. Now, normally you might be saying, hey, why didn't these two cancel each other in a sense? You know, how in the composition, they will undo each other and you get back to where you started. Normally that happens. However, in this restricted world, you have to return an angle that is in the range for the arc sine. The arc sine's on the outside here. So we got to be careful about that. Okay, back over here now. Again, same thing. We have to be careful. You have to ask yourself, is -pi over 3, is that in the range of the arc cosine? No, it's not. We need a number between 0 and pi. So we can't just say we cannot say that that's -pi over 3, since this is not on this interval. So you need another angle that will give you the same result as a cosine of -pi over 3. So that's down in the fourth quadrant, and that cosine would be a 1/2. So we want the arc cosine 1/2. Well, that would give us the pi over 3. The angle whose cosine is 1/2 is pi over 3. And that fits in this interval. Okay, so you're just working backwards with these functions. Be careful. Don't want to give the wrong answer, even though you might be thinking logically correct.